Let's take a look at an example of finding the remaining balance on a loan. In this case, we have after making 21 payments of $663.70 on your original 5-year $35,000 car loan at 5.2% compounded monthly, you want to find the amount that remains. What is the amount of the remaining balance of your car loan? All right, one thing, the information in this problem is not all there, but there's enough for us to make an assumption. In this class, the compounding rate matches up with the payments rate, or else the formulas are just not even, they're just so messy. Let's put it that way. So it should have said after making 21 monthly payments, but who makes $663 another type of payment on the car loan? So this is pretty much what everyone assumes, but I just wanted to say that it wasn't there and we have to assume that it is. So these are monthly payments. This is a car loan. We have the monthly loan formula here on the right. It's the one with the negative exponent because the amount we owe on the car will decay or shrink until it gets to 0, and that's what this negative exponent does. It shrinks the balance until it's 0. Okay, now this is an interesting value, $35,000. That's how much we originally had borrowed from the bank. But we've already made some payments. So $35,000 is no longer how much we owe the bank. It's not that value. So in fact, the $35,000 is not going to be used at all. We want to know how much is now the balance after the 21 payments has been made. Next up, the 21 payments is actually the NT value in our formula. It's not a specific amount of years, so it's not a T value. The number of payments is what NT represents. So how we use the loan formula is we basically ask ourselves, what would happen if we continued to pay this monthly payment at the same interest rate, the same frequency, but let's see, 5 years equals 5 times 12, 60 months. 60 months minus the 21 months that we've already paid is 39 months. That's how many months are left over. If we used 39 for the how many payments are left over, and again at the same interest rate and the same frequency, how much could we pay off as if it were a loan? So we're still using the monthly payment. We're still using the same interest rate, the same frequency, but instead of using all 60 months, we only have 39 months left over. And we don't use the 35,000 because we've already paid some of it back. This calculation will give us how much money we still owe the bank. So let's calculate this and see what we get. I'm going to take the classic version of the calculator for this example so we can practice using all the parentheses we need. Open parenthesis 1 minus open parenthesis 1 plus 0.052 divided by 12, close parenthesis, exponent. Here we need a parenthesis because there's a negative along with that 39. Without that parenthesis, the negative would be the only exponent and the calculator would say there's an error. Right parenthesis, divide by. The denominator also has an operation, so parenthesis around that as well. And finally, we get that we still owe $23,768.02. So we paid a good amount off of this $35,000 car, but we still have some left over. So we have to figure out how many payments are left. That's what NT will be. And keep everything else the same and work out P sub 0. All right, your turn. Go ahead and pause the video and see if you can work out this next question. What you should get is P sub 0 is $19,282.85. Okay, pause it again and work out the next question. Before you do, I do want to say that this value is not how many payments you've made, it's how many years have gone by. So this time you can't use the remaining as the NT, you have to figure out how many years are remaining and use that for T and stick with the same N equals 12. All right, pause it and see what you get. So what you should end up with is P sub 0 equals $277,303.88. All right, I hope this helped.